My name is Michael Bent, and my student ID is 9271238, and this is my bench assessment. In the final project group, I worked alongside Leah. The aim of the project was to create a system that could accept 5 passwords and store them for future checks, as well as check the light level and temperature of the factory after the password was correct. If the password was wrong, then a 50-second system lock was to be implemented. The risk of making a system such as this comes from the manufacture and maintenance of the system, as when making a PCB, harmful chemicals are used to create a PCB board, the same as with soldering. If after implementation of the system any of the components fail, it could lead to loss of product in the warehouse. The UML flowchart shows the password system. The flowchart starts by unlocking the system and then setting up the timer interrupt 1. Afterwards, checks if the previous passwords are stored. If not, asks for the passwords of 3 digits to be stored. Next, the system checks if the passwords stored are correct against the new input user's passwords. If correct, the system grants access. If incorrect, the system is locked for 50 seconds. This is the flowchart for if the password was correct and access was granted. This is the light detection system that runs continuously, and the temperature interrupt started with interrupt 0. The temperature interrupt is triggered every 6.5 seconds, and if 6.5 seconds have passed, then the count needed for the time is reset, and a temperature is collected and the value is stored. If 3 temperatures are stored, then an average temperature is made and displayed. If the temperature is above 20, the system does not give the interrupt. This flowchart is for the 50-second interrupt, as shown. The interrupt starts by counting 50 seconds and then checks if 50 seconds have passed on the count. If 50 seconds have passed, then the count for the interrupt is reset and the system lock D is set back into the unlocked state. If 50 seconds have not passed, then the system returns to counting. This is the circuit schematic with all inputs on port A and outputs for the system on ports B, C, and D. As shown in the simulation, the system accepts 5 passwords and checks if they are correct or incorrect. If correct, light detection takes place along with the average temperature displayed. If the password is incorrect, then the system is locked for 50 seconds. As shown by this piece of code, the system checks the taken user input and checks at specific EEPROM addresses for each digit of the input. If the 3 digits match the address stored digits, then a welcome response is given. This is used for all 5 passwords, with each password having its respective EEPROM address. In the code is the threshold detection for the 3 LDRs. The code checks the ADC value stored in the variable result against the ADC equivalent of 2.5 volts. If the result is greater than 511, the ADC equivalent, then the LED connected to port B turns off. If the value is less than 511, then the else turns on the respective LEDs. This is the code for the temperature sensing, and this shows that an average temperature is created and the temperature is used to create reminders, which are then stored for display on 7 segments. This is the PCB design with inputs on the left, outputs on the right, with the connectors for the 7-segment displays with ADC converters on the bottom, along with the connectors for the Bluetooth device. The resistors were chosen to be 1.8 inches due to real-world sizes. The bill of materials is a list of real-world prices for the components selected in the schematic circuit, with both price and quantity taken into account. For environmental concerns, to make the system, finite resources such as copper will need to be used in the process of creating the PCB. Harmful chemicals are used and need to be disposed of safely after use so as to not harm the local environment and wildlife ecosystem. These are the references for the UML flowcharts and the bill of materials. Thank you for listening. This was my bench assessment.